Hello and welcome. In this video, we're going to be discussing how to solve rational equations like the one you see on your screen. So my preferred first step in solving rational equations is to clear out the fractions without changing the balance of the equation. So our first step in doing that is to find the least common denominator. So the way that we're going to find that least common denominator is we're going to start by factoring our denominators. So if you look at the first term that we have, the denominator really can't be factored any further. So we're going to ignore that one. But if we look at this guy, it can be factored. So it's a trinomial, so we'd want to use a technique to factor this guy. So if you've watched any of my other videos on factoring trinomials, you can use one of those techniques or any other way that you've learned. So if we do factor it, that's going to be our first step. So the first guy is going to stay the same because there's nothing we can do to factor him further. On the other side, that bottom does factor into w minus 4 times w minus 2. Okay, so now if I want to find that least common denominator, that's really my second step. So step 2 is find the least common denominator. And so remember that least common denominator is going to be a multiple of our denominators. So that means in this case it's got to have a w minus 2 factor in it to be a multiple of this guy, and also to be a multiple of this guy it has to have a w minus 2 factor. It also has to have a w minus 4 factor in it. So our least common denominator is going to be w minus 2 times w minus 4. Our third step then is to distribute that least common denominator to both sides of my equation. So I've just written out the next step, which is, again, we're going to distribute that least common multiple to both sides of the equation. So what I've done is just rewritten our equation. I've left a little bit of extra space because what I'm going to do is multiply both sides by our least common denominator. So I start by just putting each of my original terms in parentheses, and then I'm going to multiply both sides by w minus 2 times w minus 4 over 1. And then I just want to clean up what's left. If we've done everything right, we should end up with an equation that has no fractions in it. So here we go. Notice in the first, if we look at the first term, we've got this w minus 2 on the bottom, this w minus 2 on top. So if we divide top and bottom by w minus 2, what we're left with is negative 4w times w minus 4. On the right hand side, if we clean things up, notice I have a w minus 2 and a w minus 4 factor on top, and a w minus 4 and a w minus 2 factor on the bottom. So I can divide top and bottom by those factors, and that just leaves me with 1s. So if I multiply what's left, I just have a 16 on top. On the bottom, I just have 1. So I don't even need to write the fraction bar. Just going to leave it at 16. Alright, so then my final steps are just to solve the remaining equation. So step 4 is just to solve the equation. So I'm going to start that process by distributing that negative 4w through on the left-hand side. So if I do that, I'll have negative 4w squared. Negative 4w times negative 4 is plus 16w equals 16. And now this is a quadratic equation because I have that w squared term in there. So to solve quadratic equations, well, there are a few different techniques. But one technique is to try to factor the expression. So to prepare ourselves for that, I'm going to move all of my terms to one side of the equation. And because I like working with positives, I'm going to get rid of the negative 4w squared by adding 4w squared to both sides. And then I also have to move the 16w, so I'm going to subtract 16w from both sides. If I do that, on the left-hand side I'm left with 0. On the right-hand side, if I put my terms in order, I've got a positive 4w squared minus 16w, and then plus 16. And now I'm going to try to factor that expression. So I'm just giving myself a little extra room here. So notice one of the things that I can do is I can factor the 4 out of all those terms. That leaves me with w squared minus 4w plus 4. And now I want to try to factor this trinomial inside. And again, I would use one of the techniques that either we saw in a previous video or that maybe you learned elsewhere. But this guy does end up factoring pretty nicely for us. It factors into w minus 2 and then times another w minus 2. So then the last step, once I've factored it out, is to set each factor that contains a w equal to 0. So I've got w minus 2 equals 0, and then another w minus 2 equals 0. I don't need to worry about the 4 in front because no matter what I plug in for w, this guy will never equal 0. So I can ignore that factor. So I'm just focused on this factor and this factor because depending on what I plug in for w, it can make these guys zeros. Okay, so now if I just solve each mini equation, I'm left with add 2 to both sides here, add 2 to both sides, I'm left with w equals 2. And then since the other factor is exactly the same, I end up with w equals 2 again. So remember that because this was a rational equation, I don't want to box it in yet. I still need to check to make sure that the solution is valid. Okay, so I've pulled the original equation over, right over here. And now if we look at our solutions, w equals 2, w equals 2, I can see right away that when I plug 2 in for w here, that's going to create a problem because I'll end up with a 0 in the denominator. And anytime I end up with a 0 in the denominator, it means that I'm undefined, so it's not a valid solution. So I have to cross our solution out, and we call it extraneous. And obviously the second one is the same because it's the same exact solution. So what we found is even though we got a solution, it actually didn't work when we plugged it back into the original, and that means we're left really with no solution here. By the way, I could have also seen that if I plugged 2 in for w in the second denominator, you would have also gotten 0 for an answer, which would have created the same problem. So either way, I would have had a 0 in either denominator, and that again creates what we call an extraneous solution, or defines our solution as extraneous, rather. And that means that we have to cross that solution out. Okay, so here's another example. Pause the video and then restart it after you've given it a try. Okay, so if we follow our steps, our first step is let's factor the bottom so we can come up with a least common denominator. The first guy can't really be factored any further. The second guy does factor into v minus 6 times v plus 2. So then I want to come up with a least common denominator, or least common multiple. And so our least common multiple has to have a v plus 2 in it, and it also has to have a v minus 6 in it. So our least common multiple would be v plus 2 times v minus 6. So now what I want to do is distribute that least common denominator to both sides of my equation. Okay, so I've rewritten my equation down here, and now I'm going to distribute this guy to both sides of my equation. So I'm going to start by putting my terms all in their own little parentheses, and then I'm just going to write v plus 2 times v minus 6 over 1 in front of each term. Just distributing this to both sides, and then I just clean up what's left. So notice in the first, if I look at the first term, I've got a v plus 2 on the bottom, I've got a v plus 2 on top. So I can divide out, and then what's left is negative 2v times v minus 6. On the other side, I've got a v plus 2 and a v minus 6 on the top, and a v plus 2, v minus 6 on the bottom, so I can divide top and bottom by those factors. And I'm just left with a negative 32. And now if I distribute on the left-hand side, I'm left with negative 2v squared plus 12v equals negative 32. This is again a quadratic, so I want to get all my terms on one side. So I'm going to add 2v squared to both sides. I always like my squared term to be positive. I always like the coefficient to be positive, which is why I'm moving the terms on the left to the right-hand side. I'm also going to subtract 12v from both sides. So on the left side, I'm left with 0. On the right side, if I put my terms in order, I've got 2v squared minus 12v minus 32. And now this is quadratic, so I'm going to try to factor it. One of the things I notice is I can pull a 2 out of all my terms, which leaves me with v squared minus 6v minus 16. And then if we factor this guy, it turns out that it factors pretty nicely. We get v minus 8 times v plus 2. And now if I take each factor that has a v in it, set it equal to 0, and solve, I get two solutions. So the first solution is v equals 8. The second solution is v equals negative 2. Okay, I can't box those in yet because I do need to check them in the original. So that's my last step. Okay, so I brought our original equation right underneath our two candidate solutions. And so all we have left to do is to check to see if v equals 8 produces a 0 in the denominator and whether a v equals negative 2 produces 0 in the denominator. So it's probably easier, I could check the solutions in either one of these two forms. So remember when I factored this first guy, it factored into v minus 6 times v plus 2. So I can check these solutions in either this first form of the equation or the second form. But notice the second form is actually really nice because I can see right away whether either one of these factors would end up being 0 if I plugged in my number. So let's do the v equals 8 first. So if I plug 8 into this first factor, notice I would get v plus 2, that's 10. So I get 8 plus 2 is 10. If I plug 8 in here, I get 8 minus 6 is 2. If I plug in 8 in here, I get 8 plus 2 is 10 again. So the bottoms are not going to be 0. That means that v equals 8 is going to be a good solution. So I can box that in. On the other hand, if we look at v equals negative 2, right away, notice if I plug it in right here, negative 2 plus 2 is 0. And then no matter what I get here, 0 times that guy is going to end up being 0. Same thing on the other side. If I plug negative 2 in, I get 0 on the other side. So right away I can see that that solution is going to be what we call extraneous. So our only solution is v equals 8.